Hey everyone, welcome to our cold day. So today we are going to work through a worksheet on protein synthesis and how we kind of go from DNA to mRNA to tRNA to then coding for amino acid. And doing this process is going to set you up for your virtual day on Tuesday, where you're going to go through and code for different amino acids that will help express different traits in something called a unigriffin. So by doing this activity today together, hopefully we'll still get you the building blocks for that virtual day assignment. So ideally, you're probably going to have two devices if possible, so you can kind of watch this video and be working with that other thing as a PDF if you don't have access to a printer. Printing off the packet called Protein Synthesis and Amino Acids, I think is what it's called, is going to be the best bet, just because then you can probably do it that way. Or two devices and marking up the PDF that's linked in Canvas is going to be a good option as well. So here we go. All right, so let's take a look at this worksheet that you're either printed or you are marking up through Canvas. So a couple things we're going to do, just to kind of remind you of a few things. When we go through and we are talking about a nucleotide, and the nucleotide, remember, is the monomer of nucleic acids. Our phosphate is this thing right here. Our nitrogenous or nitrogen-containing base is here. That could be our A's, T's, C's, and G's. And then our sugar is this one right here. So those are the three building blocks of, or the three parts of a nucleotide, which is the monomer of our DNA molecules. So a couple things here just real quick. There's a sugar phosphate, sugar phosphate, sugar phosphate. I'm not going to spend the time going through and color coding all that. I just kind of want to quickly review with you that, remember, according to Chargaff's rule, for every C there's a G, and for every for every T there's an A. So if we kind of look at our coding here, these ones that kind of make the curve shape right there, those are all going to be the letter G's. So this is going to be a G, this is going to be a G, and then this one's going to be a G. And then all of the ones that have like this little, I don't know, alligator mouth type thing, those are going to be T's. So this is going to be a T right there. Okay, and then using Chargaff's complementary base pairing, we have C's, C's, A's, and C's. Okay, so that's the idea of complementary base pairing that we're going to be building off of. So a couple of things, just remember that when we have a DNA strand, we have a coding and a non-coding side, and they do complementary base pairing. The process to go from DNA to mRNA is called transcription, and then from mRNA to tRNA is called translation. So then it talks about translating the mRNA into amino acid, or transcribed mRNA. That's what they're referring to. So that's exactly what we're going to be doing here. So when we go through and we use complementary base pairing, for every A there's a T, for every T there's an A, for every G there's a C, and then we can go through and say, well, for every G there's a C, for every T there's an A, for every A there's a T, for every G there's a C. Okay, why don't you hit pause on your video and you fill in the rest of your DNA strand, and then unpause it when you're done. All right, so then what you should have gotten is a G, an A, a T, a T, a G, an A, and an A. So that's the complement of the DNA strand. Now, through the process called transcription, we're going to go from DNA to mRNA. So this is called transcription. Okay, so when we go from DNA to mRNA. Now remember, when we transcribe things, for every A, there's a U, because there's no such thing as a T. Okay, so for every T, there's an A. For every A, there's a U. For every C, there's a G. Okay, now we're just going to build up that. For every C, there's a G. For every A, there's a U. For every T, there's an A. For every C, there's a G. For every G, there's a C. And for every A, there's a U. Remember, there's a U. There's no such thing as a T. Why don't you do the last 6 together? Hit pause, unpause once you get to the end. All right, the rest of these should then be A, C, C, U, U. Okay, that's how That's called transcription. Then the next step is going from mRNA to tRNA is called translation. That process is called translation. And translation is still RNA, so there's still no such things as T's. So for every A, there's a U. For every U, there's an A. For every G, there's a C. And then we just follow that pattern. So for every G, there's a C. For every U, there's an A. For every A, there's a U. For every G, there's a C. For every G, there's a C. For every A, there's a, or I'm sorry, for every U, there's a A. Okay, you try the next 6. Hit pause, unpause it when you're done. All right, so the last 6 should be U, U, G, G, A, A. Okay, so that's translation. Now, keep in mind what's happening here. I'm just going to show you this picture. This is on page 3. So on page 3, what's going to happen is what we just did is we went from DNA to DNA, and then we went from DNA to mRNA. That's called transcription. Then these 3 mRNA, called a codon, will bring in these 3 anticodons of tRNA. But attached to these 3 anticodons is a specific amino acid. So depending upon what 3 bases these are, it's a different amino acid. Depending on what 3 those are, this is a different amino acid. Okay, so that's the idea. So now we've coded for words and things like that. Now instead of saying words, we're going to do the amino acids, because that's the building blocks of proteins. We put a bunch of amino acids together, we produce a protein. Proteins express traits. So that is what we code for. Now we've used a table in the past to say, well, I'm going to go through and I'm going to code for those 3 base pairs, right? And we coded for that with DNA. For our name in DNA, we coded for that for some words. But now we're going to use the actual amino acids, which happens in our bodies. Okay, so now what we're going to do is, now that we've gone through and we've done our translation, what we're going to do is we're going to look at what amino acids is going to be built. Now, I just had some editing things, so if this doesn't edit quite right, I apologize. But what we went from DNA to mRNA, mRNA to tRNA, and then these tRNAs are going to bring in the amino acid. We got to make sure when we look at this chart, this is a little bit different chart than what we've been doing before. This chart is called for a codon. This chart is mRNA. This is an mRNA chart. It is not a tRNA chart. This is an mRNA chart. So when we look at this, we look at the 3-letter sequence for amino acids. For our mRNA, and our first letter of our codon, our second, and then our third, and then we'd get that amino acid. Or our first letter, our second letter, our third letter, this would be our amino acid, okay? So just so we are clear, yes, we did do transcription and translation, but this and this column right here, my mRNA, is coding for the amino acid on this chart, just so we're clear on that. So we are looking at these 3 letters, A, U, G, and if we go to our chart on page 4, our first letter, these are our first letters, our second letters, our third letters, and finally our amino acids. So A is my first letter, my second letter is U, my third letter is G, so we are going right down this track, right? So A, U, G, our amino acid is MET or M, or if we really wanted to write the full name, we could write out methionine. But this little arrow, this is our start codon. And this is going to say, let's start coding for our thing right here. So I'm going to do the 3-letter just because it's a little easier and I'm kind of lazy sometimes. So the next sequence that we're looking at are G, U, A. So if we come over here, our first letter is G, U, A, and we're going to code for val. Okay, so that's going to be what our second amino acid, this is codes for the amino acid val, for valine. Then we are, and you can kind of see we have these dividers right here, right? So now we're right here, right? So we have GGU. So if we go to our chart, and I know there's a lot of scrolling, GGU, U, this is GLY for glycine. Okay, so that's our next one is GLY for glycine. Then AAC, why don't you try that one? Hit pause, and when you're done, unpause it. All right, AAC is ASN. So my amino acid for this one is ASN. Last step here is you are going to code for CUU. Try it, hit pause, unpause when you're done. CUU coded for Lu. Okay, again, CUU codes for Lu. Okay. So that's the idea of these. You just got to make sure you're always keeping track of what codes for what. And the idea is this chart coded for this and this. The mRNA coded for the amino acid, but it's the anticodons here that are actually bringing in the amino acids that we'll talk more about in class. But this is kind of meant just to kind of give us that background. So when you are doing your virtual day on Thursday, you can actually use that same idea for building amino acids, and then that will express traits on a mythical creature called a unigriffin. So that's to come on your virtual day on Tuesday. If you have questions, please join Mr. DeGrand or I in our office hours today. Have a great one.